Okay, Assalamualaikum warahmatullahi wabarakatuh. This is a midterm 2 exam simulation. This is taken from mid-semester examination 2, semester 2, 2022-2023. Hopefully, this will be a simulation that will help or can help some of you in preparation for midterm 2. Right, to put into context, in case later on the implementation is different. So in the past we have, for example, during my teaching of this course, we have a period where we have only one midterm exam from chapter 1 until chapter 4 or 5, depending on when it is being done. Or then now currently we have two midterm exam. Midterm 1 is from chapter 1 to 3, and midterm 2 is chapter 4 and 5 mainly. Right, of course, when we say it covers chapter 4 and 5, many of the fundamentals from chapter 1 to 3 is embedded, included, right? But the question in itself is mainly from chapter 4 and chapter 5. So that's the context, and yeah, without further ado, let's go into the question. So this is the question paper, midterm exam 2. In this case, the time given is 1.5 hours. So right now we started recording at 10:45, meaning 11:45, 12:15. So we should finish by 12:15, right? So there's two questions. Of course, make sure you read all of the instructions. Okay, question number 1, we have 50 marks. Okay, basically we have here, oh, it's not given here. Anyway, question 1, 50 marks, meaning question 2 is also 50 marks. Question 1 is part A, B, and C. So you can see there's a diagram here, and the question asks for a resultant moment about point A, so moment about point. Replace equivalent force and couple moment. So this is simplification, or equivalent force and couple moment system, and then equivalent force and its location, right? So this is simplification, right? And then part D, E, F, G, we have 3D, and you have similar thing. Of course, the difference is this is 2D, this is 3D, but we still have to find, in this case, moment about point as well as moment about an axis, right? And then question 2, another 50 marks. Here is equilibrium problem. We have to identify the support direction, of course, determine direction on the bent rod. So basically, support direction, what is the value, and of course embedded here is distributed loading. And then question 2B, we have 3D, and then determine the component of reaction, right? So the question is straightforward in the sense that question 2 is testing you on moment. Both we have 2D and 3D, and then question 3 is support action, or equilibrium of rigid body, 2D and 3D as well. So right, so we'll move to question number 1, where we'll start to answer each part, right? Alright, here we go. Question number 1. So again, we have this diagram to deal with. So we need to find, okay, now when you see this diagram, of course similar diagram or similar object can be given for equilibrium of rigid body question as well, right? You might be asked about support reaction here, but make sure you understand what the question wants, and do not just by the diagram you guess what the question wants. So when the question just simply asks for calculation of moment, do not draw the free body diagram and calculate support action, right? That's not what the question wants. Alright. Sorry, so here the question actually specify using scalar calculation, so do not use a vector. Determine the resultant moment from forces about point A. So it's forces about point, and this is point A. Second is simplification, right? So let's put this on the side, maybe a little bit bigger to see the diagram. Can it fit? Okay. All right. So the question says, determine the resultant moment of forces about point A. Point A is here, not here, right? So let's go into answering the question. Question 1A. We want to find moment about point A, right? So we do summation of moment about point A, and we have to set which direction is positive. Let me say 600 is bigger, so let's say clockwise as positive. Let us say that. So alright, so we have two forces, 600 and 300, but of course to calculate this one, okay, it is interesting in the sense that you either resolve into normal x and y, or you resolve along this, right? But the angle given, I think it might be easier to use x and y. So we'll do that. So let's start with the 600 here. So horizontal one will be clockwise, so positive. So we have 600. Horizontal is cos 20 degrees. The distance would be 0.8 sine 40. 0.8 sine 40 degrees. Okay, so that's the horizontal. The vertical one will be counterclockwise, so it's negative 600 sine 20 degrees, and the distance would be cos, right? 0.8 cos 40 degrees. Alright, and the 300, let's take vertical first, so it's counterclockwise, so minus 300 minus 300, 4 over 5, 4 over 5, and then the distance is 0.4 sine cos 0.4 cos 40 degrees, and then also minus 300, 3 over 5 sine 0.4 sine 40 degrees. Those are two forces. Alright, so let's calculate. Let me have my calculator. 600 times cos 20 times 0.8 times sine 40 degrees. So where's my 289.9309. Okay, so 600 times sine 20 times 0.8 times cos 40, so minus 125.7613. 300 times 4 over 5 times 0.4 times cos 40 minus 73.5403, and then 300 times 3 over 5 times 0.4 times sine 40 minus 46 2807. 2807. And if we calculate this, 289.9309 minus 125.7613 minus 73.5403 minus 46.2807. So you'll get 44.35 Newton meter. So it's positive, meaning it is clockwise, right? Alright, so that's basically the answer, because the question straight away says determine the resultant moment about point A. Alright, moving on to question B. The question B asks for simplification, right? Replace the two forces with equivalent force and couple moment about at point O, and then draw the structure with the equivalent force and couple moment. Okay, so we have to calculate and we have to draw. So basically, in the end, you have to have the FR, you have to have the theta, which is the direction, and you have to have the moment, right? That's the three elements that you have to calculate. So summation of fx, let's take to the right as positive. So 600 cos 20 degrees minus 300 3/5. So this is basically 600 times cos 20 minus 300 times 3/5. 383 81 56. Summation of Fy, taking upwards as positive. So you have 600 sine 20 degrees plus 300 4/5 445 445.212 212. So what this means is basically we have to the right 383.8156 Newton. We have upwards 445.2121. We have FR and we have theta. FR is square root of 383.8156 plus 445.2121. Three 383.8156 square plus 445.2121 square 587 587.816 Newton. Okay, I'm doing this while I'm sleepy. I'm not sure why. Oh, my eyes is red already. Okay, so 445.2121 383.8156. I'm not sure how many of you, because saying about 2121, right? But of course this joke is in Malay. If you have if you have heard the joke about you know, the plate number, and someone have to identify, and he reply PK2121, it's actually PK2121, right? PK2121. But of course, as a Malay, we heard as PK2121, meaning think, ladies and gentlemen, or gentlemen, something like that. Anyway, so that's side story. Not sure why saying 2121 remind me of that. Arctan 445.2121 divided by 383.8156. 49.2. 49.23. Okay. Now, as a final answer, I will I will cut this down, but because we will use this value, if you are using this value for further simplification, so that's why I do not round off this yet. So okay, so we have to FR here already, so moment, right? So we have to calculate moment as well. So okay, is it because it's further, right? And we have more counterclockwise, right? So let's see. Summation of moment about point O. Let's say counterclockwise as positive. Let's start with 600. So we have something similar as before, but is the distance have to be add 1.2, right? So we have okay. So now we take counterclockwise as positive, right? So if this is okay, let's start with the 300 first. So it's 300, so plus, so we have 300. Let's take vertical one, 4/5, and the distance would be 0.4 cos 40 degrees plus 1.2. So, and then horizontal also plus 300, 3/5, and then we have 0.4 sine 40 degrees. And then for 600, the horizontal one, okay, let's take vertical one first. For vertical, so plus 600 sine 20 degrees, and then 0.8 cos 40 degrees plus 1.2, and then minus 600 cos 20 degrees, so this is like that, 0.8 sine 40 degrees. So from here, (300) times 4 divided by 5 times bracket 0.4 times cos 40 plus 1.2, 361.54. Uh, 5002. Okay, to verify, 0.4 times cos 40 plus 1.2 times 300 times 4 divided by 5, 3615402. Next, plus 300 times 3/5 times 0.4 times sine 40, 46.28, 07. Okay, this one is the same as before about E, right? Because it doesn't change Okay, plus 600 times sine 20 times 0.8 times cos 40 plus 1.2 372.0158. Just verifying. 1.2 times 1.2 plus 0.8 times cos 40 times 600 times sine 20. Okay, and then minus 600 times cos 20 times 0.8 times sine 40 minus 289 9309. Now, so if we add everything, 361.5402 plus 46.28, oops, 07 plus minus 289 489.9058. Okay, so we have calculated. So someone called, but I'm recording, and I'm not sure whether it's so obvious that I'm so sleepy. So, and it really drags the flow and the pace of me, because I'm become sluggish, right? So that's this is just a reminder before the exam, have enough sleep. Otherwise, your brain actually do not function as optimum. Anyway, so where was I? So I even forgot what this is about. Okay, so we have to draw. So we have the whole thing. And then what we have done is replacing it with the equivalent force and couple moment, right? So force is 587, so in that direction at point O, right? 587, is it? 587.8 Newton. And then the angle is 49.2. And then you have moment. Okay, what is the direction of moment? Is counterclockwise. Right. So we have counterclockwise 489.9. Right. So that's the answer for part B. Alright, so moving on to part C. C is, as we have read before, further simplification, right? Replace the two force with an equivalent force. Okay, so it doesn't, the question doesn't actually say further simplify, but it just say equivalent force. So meaning there's only one force remaining, hence it's further simplification. And specify its location and draw the structure as well, right? Alright, so with that, so what we want is from here, right? So, oops, further simplify is something like that. So if we have only force 587.8 Newton and 49.2 degrees. But what is this distance here, right? So let's say this is x, or maybe d. Let's say d. So what is that distance d, right? So that is the only one that we need to calculate, right? So either way, right? So if you look just here, the moment produced by this about point O, it should be the equivalent to the moment here, right? So if we do that, hence we will use the FR as well as theta here. So that's why I want to use this value here, so that the error is less, right? So 587.816, right? So in that case, the whole moment, so basically MR should be summation, should be summation of FD basically, right? FD, yeah. So FR is MR, sorry, MR is 489.90858. So equal to, of course here the horizontal component doesn't produce any moment because it goes through O. So the summation of moment is simply just this is counterclockwise, right? So this is counterclockwise. So if you take everything counterclockwise, so it become 587. Wait, 587.816. And then sine, what is the angle? 49.235. Okay, that is the force times the distance, right? So if we calculate this one, 489.9058 divided by 587.816, and then divided by sine 49.235. You have 1.1. So D 1.1 meter. Right. So there you go. That's what we have to calculate for part this part, right? A, B, C. Right. So moving on to the next part of the question, part D, E, F, and G. Moving on for part D, E, F, and G. Right, so here we have to calculate 4 different moments. Moment about point, moment about point, moment about line, right? From the same diagram, right? So this all will be using cross product. So let's go one by one. So can this be seen clearly? This is 100 Newton, right? Okay. So I think this is still visible, right? Okay, let's okay, so question 1D, right? What we want is moment by F1 about point O, right? Moment from force 1 about point O. So moment about point O, this is moment about point, right? So M, so it's from M equal to R cross F, right? And R is from point to force, right? So in this case, ROA, right? ROA. Then cross F1, right? Verify. Moment force 1 about point A. So force 1, OA, and force 1. Alright. So that is what we need. So ROA. So ROA is simply the height is 2, right? So it's 0i plus 0j plus 2k basically, right? Because 2 meter upwards. And then F1 is 200 cos 35i, and then plus 0j, no j component, and then plus 200 sine 35k Newton, of course. This is meter, right? So we can plug in straight away, right? Okay, should I write more smaller or something? So input into the matrix, so you have I, J, K, 0, 0, 2. Okay, I should have calculated. Okay, no man. 200 cos 35, 0, 200 sine 35. Both are positive, right? Alright. So to solve this one, I 0 minus 0 minus j 0 minus 2 times okay, let me calculate. 2 times 200 times cos 35, 327.66, and then plus k 0 minus 0. So basically you'll have minus plus 327.66 J Newton meter. So that's the answer. Nice and easy. So part E. Moment by force 2 about point A. So it's moment from point A. So moment about point A, from A to point to F2. So RAC cross with F2, right? So RAC negative 1i plus 1j plus 0k, right? There's no elevation. Negative 1, positive 1. Alright. F2 100 Newton. So x, so it's negative direction, right? Negative 100 cos 40 sin 30, and then plus 100 cos 40 cos 30, and then plus 100 sin 40. So calculating this one first, so that when we put into the matrix, it's not that long. 100 times cos 40 times sin 30 minus 38. Sorry, this is I, this is J, this is K, right? Minus 38.30 I 100 times cos 40 times cos 30 plus 66 34 100 times sine 40 plus 64.28. Now we are ready to put into the matrix. A I J K minus 1 1 0 minus 38.30 66.34 64.28 so we have I 64.28 minus 0, right? And then minus J minus 64.28 minus 0. Wait, what? Okay. Plus K minus 66.34 minus become plus 38.30. So minus 28.04. Let me double check. So it's minus 66.34 minus plus 38 point. Wait, that's the answer, right? Oh, I have to simplify. 64.28 I plus 64.28 J minus 28.04 K. Okay, that's part E. Moving on part F. Oh, I'm so sleepy. So sleepy. MashaAllah. I'm doing this so slow. I'm not sure whether I managed to finish on time because I'm doing this so slow. Okay, moment for this F2 by force 2 about line OA, right? So in that case, we have unit vector of OA, and you have two options basically, right? So if you want to do this, so moment is basically either, because UOA is obvious, dot, but R can be from O or can be from A, right? So for example, R AC cross F2 or UOA dot ROC cross F2. Both should give you the same answer, right? So let's, okay, what is UOA? UOA is simply 1K, right? We'll take upwards. RAC and F2 is already there, right? This one, right? RAC and, let me write, RAC as F2 as above. but R OC is minus 1i plus 1j plus 2k, right? F2 is F as well, right? So if you calculate here, M, so if you put into matrix 0, 0, 1, so RAC minus 1, 1, 0, right? Minus 1, 1, 0. And F2 minus 38.3 minus 38.3 666.34 64.28. Okay. Of course, if you do the other one, the only difference is ROC, right? So it becomes 0, 0, 1 minus 1, 1, 2 minus 38.3 66.34 64.28. So if you solve here, it's basically just 0 minus 0 plus 1, and then you have minus 66.34 minus become plus 38.3. Minus 28.04. So basically minus 28.04 Newton meter, right? If you do this one, it should be also the same, right? So it's the same, minus 28.04. Okay, why am I so sleepy? Okay, so the question asks for vector, right? So m vector is m times the unit vector of the axis. So unit vector of the axis here is simply k. So minus 28.04 k Newton meter. So that should be correct. And then G, right? Moment by force 1, moment by line by force 1 to line OB, line OB. So M, so UOB dot. So it's either two things, right? So either RBA cross F. Sorry, this is about F1. Oh, okay, F1, right? So F1, right? Or M equal to UOB dot ROA, right? ROA cross F1. Alright, so RBA minus 1i. Oh, UOB is not calculated, right? So, but anyway, ROA is 2k. But UOB, okay, UOB, for UOB, we need to calculate ROB first, right? Okay. So ROB, so 0i plus 1j plus 2k. ROB magnitude, it became square root of 1 square plus 2 square set 5, right? So UAB is 0I plus 1 over set 5 J plus 2 over set 5. Okay. So now we are F1 is there already, right? F1 is above, right? Okay, we haven't calculated. So from here, okay, let me bring that down. From here, let's calculate so that it doesn't take too much time, too much space in the matrix. Satu enam tiga 0.83. $200 times sine 35 114. Now, so applying the matrix. Unit vector is that, so 0, 0, 1 over square root of 5, 2 over square root of 5. R, in this case, minus I, so minus 1. F is 163.830.114.72. So in this case, it is 0 minus 1 over square root of 5. 114.72 minus okay, and then plus 2 over square root of 5 times 0, right? Because 0, 0. So in this case, it becomes 114.72 divided by square root of 5. 51.3 Newton meter. Okay, my brain is so slow. So 51.3 times unit vector of what was it? 1.1. And it becomes okay, is this correct? Allah Akbar, my brain is so slow. Okay, let's calculate the other one first. I'm not okay, my brain is not really sure what is happening already. Right, so UOB, right? MashaAllah. What is it? Okay. 0, 1 over square root of 5, 2 over square root of 5. And then ROA is to K 0, 0, 2. And then F1 is 163.83 0114.72, right? So if I calculate from here, 0 minus 1 over square root of 5, 0, and then minus 2 times 163.83, 2 times 163.83, 327, sorry, it will negative, right? Negative 327.66. Yeah, and then plus 2 over square root of 5, 0, right? But this will be different, right? So I think one of this is wrong. 327.66 divided by 5, 146, positive 146.534. Okay, so which one is wrong? Because they have to be the same. Okay, unit vectors, okay. RBA. Oh, sorry, RBA is wrong. Masya Allah. So it's not I, it's that way. So minus 1J. So do not do your exam during sleepy state. It's not good. Minus 1. Right? So in that case, okay, let's erase this and recalculate. So 0 minus 1 over square root of 5. So this is still 0, right? So plus 2 square root of 5. Then you have 163.83, right? Is that correct? So because 0 minus become plus, right? So 163.83 divided by square root of 5. Okay, now it's wrong again. What am I doing? Why is it wrong again? Okay, so let me check. What else is wrong? Okay, which these two keys, right? Ya Allah. Minus 1G. BA, right? Minus 1G. So minus 1. So 0. Okay, nothing. 1, 5, 0, 0. Wait, did I calculate wrongly? 2 times 163.83 divided by 5. Okay, I didn't multiply by 2 just now when I calculate, so that's why I got. Ya Allah. Okay, so please do not do your exam in a sleepy state because you will waste so much time like this. Okay, of course, normally when you are doing your exam, you don't do multiple like this, right? But I'm showing this because you can choose either way. But still, interestingly, if you do both way, if you have the time, you can check. If it's not the same, one of it must be wrong. Bismillah. 146.534. I need to be doing jumping jack or something. 65.5G basically. 121. Allahu Akbar. So that is part G of question 1. So we only have limited time left for question 2, right? So we have finished, right? Part G, F, E, and D. Alright, so moving on to question 2. I have to do some jumping to... Right. Okay, question number 2. Bismillah, Ya Allah. Okay, this is based on this figure where a band rod is supported by a collar at A. So this is a collar and this fixed to the collar, and so meaning that there's a moment direction here, right? And then we have a roller here. Determine direction. Alright, so I think that can be seen, right? Question 2A. Bismillah. Question 2A. Alright, so first thing first, drawing the free body diagram. So obviously there's normal reaction here. Okay, there's distributed loading here. That's interesting. So we have one force from the rectangle, one force from the triangle, and one force from the 150 here. And then you have NA and you have MA, right? Because it cannot rotate and it's free to move up and down, but it cannot move horizontally, right? So in terms of the distance, this is 1.5 meter. For rectangle, this value, normally I hate when the lecturer give values like this because it becomes 2/3 of 0.5, right? And this one will be 1/3 plus 0.5, right? So for this one is 1/3 of 0.5 plus 0.5, because this one is 0.5, right? Because here there's half here and half here, right, for this distance. And then this is 1 meter with the degree of 40 degrees. Okay, my drawing is also become haywire now. Okay, distributed loading. Okay, 100 Newton. Okay, so for the rectangle is 100 Newton per meter. Okay, so I'll calculate here. 100 Newton per meter times 1 meter becomes 100, right? So this is 100 Newton. While the rectangular is half times it is 100 times 0.5. This means 25. Where's my mouse? 25 Newton. 25 Newton. Alright, so that's the free body diagram, a messy one, but you know, hopefully you can draw better than this in the exam at least. Alright, so what to do to solve the support action? Alright, so let's do the easiest one first. Summation of fx. Summation of fx equal to 0 and a equal to 0. Solved, right? Because there's no other horizontal. Summation of fy equal to 0 upwards. Okay, I cannot see. So we have NB minus 150 to 525 minus 100, and B equal to 150 to 5 100 275. And then moment. Okay, I assume moment counterclockwise. Would it be okay? Never mind. It's an assumption. Right? Summation of MA equal to 0 if you take counterclockwise positive. So you have MA obviously at that point. And then this one clockwise, so minus 150. A distance of 1.5. And then minus 25. Okay, what is that distance? 2 divided by 3 times 0.5. 1 over 3. So 1 over 3 plus with 1.5. 11 over 6. Okay, put that. 11 over 6. And then minus 100. Minus 100. The distance is... Okay, from this perspective, we can just add what is before, right? So it's 1.5 plus 1.5 is 2 plus 1.5, 2.5, right? Because if we add, it should be... Yeah. And then NB, right? NB is 275. So that is plus 275 with a distance of, what is that? 1.5 to 3 plus 3 plus 1 cos 40 degrees. All of this equal to 0, right? Cos 40 degrees, right? Okay, so if we calculate this, minus 150 times 1.5 minus 25 times 11 divided by 6 minus 100 times 2.5 plus 275 times bracket 3 plus cos 40 . Okay, let me double check. So cos 40, right? Cos 40 plus 3, right? Cos 40 plus 3 times 275. Okay, minus 100 times 2.5 minus 25 times 11 divided by 6 minus 150 times 1.5. Okay, I got 5. Okay, let me check all. Right, it become negative, right? Okay, double checking if we miss anything, right? And A doesn't produce. Okay, what is we call it? Calculating MA, right? N doesn't produce any moment about point A. 150, 1.5. Oh, wait a minute. My free body diagram is not complete. I just realized I didn't see this. 20 Newton meter. Okay. Given that it's clockwise, so it should be minus here, right? In that case, it should minus 20. So minus 494.83. This minus means it's clockwise actually, right? What the question one? Determine the reaction. Okay, so that we have what? Okay, we have all the reaction. Right, is there anything else missing? 150, 1.5. That 25 is 2/3, meaning 2/3 of 0.5. So we have add that 100 and 100. So it's halfway half plus 1/3 there. And then the remaining is halves. So this sense should be correct. So yeah, take note of this. Because if we, okay, that's the thing, right? When we draw the free body diagram, right now because I noticed when I look on that, right, but draw out my calculation, I only focus on my free body diagram. So if we already make a mistake in our free body diagram, when we calculate, we are referring to that mistake, right? So make sure, okay, in the midterm, this is depending on how it is done, right? But so far in our midterm, the midterm is being answered on the question paper. Do I have any sample, right? It's on the question paper. But in the final exam, the question paper and the answer paper is totally separate, right? So like this is separate. But if I draw just beside the actual question here, I think it's easier to notice this. But here, because it's totally separate and I only refer to my answer paper, what just happened can happen, right? Alright. Okay, so next question, which is part B. Alright, part B. Question 2, part B. Part B is based on figure 4, where a member is supported by a square rod. Okay, this is a square rod, so meaning it cannot rotate. Unlike if it's a circle rod, right? Which fits loosely, meaning it could go up and down through the smooth square hole of the attached collar at A and roller at B. Okay, this is a roller as well, and then this is distributed rolling. Okay, determine the component reaction. Okay, same question, just 3D, right? We need to find the reaction. Okay, so free body diagram. So for free body diagram, we have this thing here. Okay, I'm okay, and then this thing here, right? So bad. All right, so y-axis is here, x-axis is here, and z-axis is upward, of course. Right. Forgive me for the very bad drawing. So here we have towards the x 3 kilonewton, towards y is 5 kilonewton, z negative 4 kilonewton. Okay, so this is 2 meter. Now there's a normal reaction here, so let me use NB, but there's a force here. Okay, half times 2 kilonewton per meter times 1, so become 1, right? 1 kilonewton, 1 kilonewton. Now in terms of the distance, so this would be because it's 1, right? So this is 1/3 meter, this is 2/3 meter, right? And the remaining is 2 meter. Okay, what is there? Okay, I'll use different color because this is confusing, right? So obviously it cannot move in this direction, so you have AX, It cannot move in this direction, so we have AY. It can move freely up and down, so we do not have AZ. It cannot rotate about X, so MAX. It cannot rotate as well about Y, so MAY. And it cannot rotate as well about Z, so MAZ. So those are the forces, and NB also we have to find, right? So let's use this one. Okay. So what is first? Is there any force in X? Yes, that 3 kilonewton. So okay. Summation of Fx equal to 0. You take positive in the direction, so we have Ax plus 3 equal to 0. So Ax is minus 3 kilonewton. So meaning that negative negative x axis direction. It's negative to the x axis direction. Alright. What about y? Y we have only, okay, this is straightforward, right? Summation of fy equal to 0, so ay plus 5 equal to 0, ay equal to minus 5 kilonewton, negative y axis direction, right? So that is solved. But z we have, okay, z we have nb, right? Because we do not have az, so we can solve nb, right? So solution of fz equal to 0, so we have nb, and then we have minus 4 minus 1 minus 4 minus 1 equal to 0, so nb equal to 5 kilonewton. So of course upwards, and this must be upward. If you suddenly have negative, that must be wrong, because roller have only normal direction there. And then so we have max, may, mz, right? Alright. So okay, because the drawing is up there, it's quite okay. Is there any many max? There's none. Anyway, there's one. That's one. Alright, so not that. Okay, summation of mx equal to 0. This is moment about x, right? So we have max, because now I draw everything in positive so that it's easy. So that when I calculate ax, ay, z is all positive, right? But if I draw in the opposite direction, I have to calculate as negative as well, right? So always assume everything in positive when you have something like this, right? Okay, what was I saying? max, and then nb doesn't rotate, 1 doesn't rotate, 3 does not, 4 doesn't, 5. So 5 it rotate clockwise, right? It rotates counterclockwise, right? It rotates counterclockwise, so 5 times 2. So counterclockwise, so plus 5 times 2. So max equal to negative 10 kilonewton meter, meaning clockwise about x axis, right? My writing is already messy. Okay, what about may? Okay, y we have a lot, right? Because nb also rotate, 1 also rotate, 3 also rotate, 4 also rotate, right? Let's do z first. Anything rotate about z? nb no, 1 no, 3 no, 4 no, only 5, right? Only 5 rotate about z. So let's do that first. Summation of mz equal to 0. So of course we have maz, and then we have, okay, is it 5 is counterclockwise as well, so positive 5 plus 5 times distance of 2 and 1, 3, right? Equal to 0, so M is Z equal to minus 15 kilonewton meter. This is clockwise about Z axis. Oh, my neck. And then we do summation of my. Okay, this is where there's more involved, right? My. And because I have to scroll, I hope I don't make any mistake because scrolling. Okay, my. Okay, my. Let's see. NB is rotating clockwise, so minus NB times 2. Minus NB times 2. 1 kilonewton is counterclockwise, so plus 1 times how to calculate the distance? It's 2 plus 1 over 3. 2 plus 1 divided by 3, 7 over 3, right? So 7 over 3. Okay. And then 4. That 4 kilonewton, it's like one, this is counterclockwise as well, and the distance is 3, so plus 4 times 3. 5 kilonewton doesn't rotate about y. 3 is clockwise, so minus 3 times 2. Minus 3 times 2 equal to 0. That's all, right? Wait, NB already have the value, right? So NB is 5. So this is 5, right? So okay, I should rewrite, but yeah, to calculate. So minus 5 times 2 plus 7 divided by 3 plus 4 times 3 minus 3 times 2. We got minus 5, minus bring on the other side, MAY, it becomes 5 over 3 kilonewton meter, or 1.667 kilonewton meter. Means counter clockwise about y-axis. Have we finished? AX, AY, and B, MAX, MAY, MAZ. Alright, Alhamdulillah, we've managed to finish. It's 12:08. We managed to finish before 12:15, right? Okay, so interestingly, question 2 is quite short in terms of the answer, right? For both answer, right? I think it's quite short, which is interesting because Alhamdulillah it becomes easier, but na'uzubillah if you make any mistake. Because if you can see the step are just several, so if you see the marks, right, 25 marks, right? If the location is 25 marks for only 1, 2, 3, 4, 5 steps, meaning each steps is it 5 steps? Drawing 1, 2, 3, 4 basically things, right? 4 basic things. So meaning that 25, meaning each is more than 5 marks basically. So if you make any mistake, then the marks that fly away is also big. So that's the thing. If you have big chunk of mark for short question, for longer question, I think this one is 25. So this one is 25 as well. 1, 2, but this is still short, right? Yeah. So yeah, that's the final exam. Not final. Sorry. I'm so sleepy. Forgive me. that is midterm 2. So as you can see, if chapter 4 and 5 is not that difficult. Just a moment. You know F times D. You know R cross F or U dot R cross F. Done. And then chapter 5 is just rigid body equilibrium. So if you know how to draw a free body diagram and summation of fx, fy, fz, summation of ms, my, mz, that's for 3D. For 2D is just x, y, and moment. You're done. You're done in a good way. Meaning you're done. Not you are done, right? Right, so I'm not sure I'm talking about anymore. I'm so sleepy. My eyes cannot survive anymore. So hopefully you have benefited from this. I cannot guarantee every semester the question is as easy as this, because it's quite easy, right? If you follow, it's very straightforward. It's very easy. I'm not sure why the question is so easy, but make doa that okay. As we have you have seen, right, when we solve this question, it's not difficult, but I know some student, when they look at something that looks complicated, oh, what is this, what's going on, because it's just combined this distributed loading to this normal question. So make sure you know how to deal with everything, because if you know how to deal with distributed loading, then the rest is easy. And this is bonus lah, because all the forces is in axis, right? There's no IJK, meaning there's no, because if all of the forces is having XYZ, the calculation might be a bit longer. Anyway, that's it. Hopefully all the best for you in your exam. See you next time.